So let's take a look at the next section. Actually 6.6-2, we're going to cross off. So all of page 10, you can go ahead and just X that out. And we're going to pick up on page 11 under 6.8. And we're just going to do part of it. So we're going to be looking at when they give you an equation and then answering some questions about it. So typically the equation will look something like this, obviously with numbers filled in. If k is greater than 0, then it's a growth. If it's less than 0, it's a decay. And this number here is the original amount, where t is time. So example 1. The size p of a certain insect population at time t in days. So really important that you're noticing the units because we're talking about word problems here. So t is in days, obeys the function, and there's our equation. And the size p is our other unit. So this is the equation. Again, we're only going to be doing problems where they give you the equation. You do not have to write it yourself. So determine the number of insects at t days. That's the bell. So we're going to go ahead and plug that in. Let me flip my iPad over. All right, so given the original equation, we're going to plug 0 in for days. Again, why? Because they're asking us to t equals 0 days. So p of 0 equals 500 e to the 0.06 times 0. So that's the number that we're plugging in for t. We're going to go ahead and use your calculator, or it's fine if you don't, either way, because we know that 0.06 times 0 is 0, and e to the 0 is 1, and 1 times 500 is 500. Again, you can also just use your calculator. So the number of insects is going to be 500 insects. All right, let's take a look at part B. What is the growth rate? So the growth rate, what we talked about in the beginning, is that n of 0. So that's the number right there. That's like your y-intercept in a sense. It's your starting point. And then if you keep looking for the growth rate is this number right here. So that would be your k, which is located next to the t. So here, our growth rate, the rate is at 0.06. So 0.06 is the growth rate. And as it says above, if it's greater than 0, it's growth. If it's less than 0, it's decay. And this 500 was your initial starting point, right? So the original amount. So now that we've identified parts of the equation, now we're going to solve some things. You're going to ask yourself, am I going to plug it in for t or I'm going to plug it in for p? So this first one says, what is the population after 10 days? So because it's 10 days, they're telling you that that's what t is, okay? So you have to make sure that you're plugging it into the correct thing. So you're just going to go back to that equation that you've been working with. So we're going to do p of 10 equals 500 times e to the 0.06 times 10. Use a calculator. You can type in all of this into your calculator. 500 e, and then you should open up, it's on your left side, it should open up a exponential, and you're going to type in 0.06 times 10 and hit enter. Type in the whole thing, and when you do, you get 911 about, and we're talking about insects. I'm going to do whole insects instead of partial insects, okay? Because it doesn't make sense to have part of an insect. So round to the nearest whole number, and we're going to have 911. If you're not getting that in your calculator, talk to me during class so I can help you, but we'll do more examples of typing that in your calculator. Again, the E button is on the left side. You probably have to press the second button first. Part D, when will the insect population reach 650? Okay, this is different. This is wants to know when will the insect population reach 650. So we actually know this time what P is, okay? We know P is 650, and they're saying when. So the question when they're saying when here means we don't know the time. So this is different. So you're not plugging something in for t. So if we go ahead and we take a look here, you're replacing p with 650, and then you've got equals 500 e to the 0.06 times t, because again, we don't know the t. So make sure that you're plugging in the 650 into the correct spot. Don't plug it in for time. It is not time. Now you're going to have to use your rules of exponents to solve. So everything that we did before, doing exponential equations, logs, etc., you're going to solve. The first thing is you have to isolate the e part. So in order to do that, you have to divide by 500, which that's going to get us 1.3, or you can leave it as a fraction, e to the 0.06 t. We want to find out what t is. We can't do anything without getting it out of the exponent. So to get it out of the exponent, you're going to take the natural log, or you're going to have to go ahead and turn it into a log, a natural log. So this is a natural log base e to the 1.3 equals 0.06 t. So again, just like normal, you have to make sure that you can go ahead and move those three different pieces. This is one thing, 2, 3. Move them to the correct spots when you go ahead and convert it into a log/natural log. When you do that, now you're able to solve for t. How? You can go ahead and divide both sides by 0.06. That cancels, and now t is left alone. So in your calculator, you are going to type in natural log 1.3 divided by 0.06. That's the exact answer. Because we're talking about a word problem, we're going to go ahead and put it in the calculator, and t is about 4.37 days. And that's the approximate answer. When will the insect population double? So a couple of things that you can kind of think about here. If you want it to double, remember it started at 500. So if you want it to double, doubling means 500 times 2. So we're going to have a total of 1,000, and that's what the population is. So this is saying p equals 1,000, because again, you want to keep track if you're solving for p or t. They're saying when will it double, and then that's saying that you don't know when it will. So you're solving for t in this case. So let's go ahead and plug in the p. So we have 1,000 is equal to 500 e to the 0.06 t. Same thing that I did in the last one. I'm going to go ahead and divide by 500 to both sides. That's going to get me 2, which is kind of like the doubling that it's asking about. You're going to do the same thing. You're going to turn it into a natural log. So put the 3 parts where they go. So natural log e of 2 equals 0.06 t. And then to go ahead and solve for t, I'm going to go ahead and divide both sides by 0.06 divided by 0.06. And that's what t is. T is exactly natural log 2 divided by 0.06. And if you type that in your calculator, you're going to get about 11.55 days. So this is exact, this is approximate. All right, last thing that we're going to do is, actually, that's going to be it for this unit. So you can go ahead and cross off page 12, page 13, page 14, and stop there. So you're going to cross off through 14. Okay, so be ready in class to do some word problems just like this. This does show up on the final. Usually there's 2 questions on this. They like this word problem a lot.